Hi, for this video what I want to do is talk to you about scientific notation and do a couple examples of converting from standard form to scientific notation and from scientific notation into standard form. So scientific notation is something that we use a lot when we are dealing with really large numbers or really small numbers. It just makes it easier to write it in this format. Scientific notation is a format in which a number is expressed as a number between 1 through 9, inclusive, so it includes 1 and 9, and multiplied by a power of 10. So I have a couple examples listed down here. 6.7 times 10 to the 9th is really 6,700,000,000. And it's easier to write it in this format or work with it. I know that some calculators will use 6.7 with an E9. So if you are using a Texas Instruments calculator, a lot of times they will express scientific notation in this format. So if you see that in your calculator, that's what it means. It's the same thing as 6.7 times 10 to the 9th. Same thing for very small numbers. Instead of writing it out, with all of the zeros in front of the 2, we can rewrite it as 2.1 times 10 to the negative 7. And with this, basically, we're counting backwards. So I have 1, 2, 3, 4, 5, 6, 7 decimal places that I had moved the decimal to the left. So anytime that you have a positive exponent, it's a very large number. Anytime it's a negative exponent, it is a small number. So again, in your calculator, this might be expressed as 2.1 e negative 7. So if you see an answer like this in your calculator that has an e, that is what it means. So different calculators use different options in this. So let's look at a couple of examples. So the first thing that we're going to do is we're going to convert from standard form to scientific notation. So the first one that we have is 0.0000371. So our goal is to get the decimal place to where it is so that we only have 1 unit to the left of the decimal place. So basically what we're going to do is we're going to count how many zeros we have. So we moved it over 1, 2, 3, 4, 5 times. So when we write this, we're going to put 3.71. We only want the ones unit over here. We don't ever want more than 1 digit to the left of the decimal in scientific notation. Times 10 to the, and since this is a small number, we're going to be dividing by 10. So we're going to put to the negative 5th power. So this would be our answer. In the second one, since we have a larger value, our exponent is going to be positive. So we basically need to count how many times we moved the decimal place from here to between the 8 and the 2. So if I count, I have 1, 2, 3, 4, 5, 6, 7, 8 places that I moved it. So I would end up writing this as 8.2 times 10 to the 8th power. So I moved it 8 decimal places. So that's all you're doing with this, is counting how many times are you moving the decimal place. So now we're going to go the opposite direction. So this time we are at 2.31. The decimal place is between the 2 and the 3. So what we want to do is count over 7. So I want to move over 1, 2, 3, 4, 5, 6, 7, so that our decimal place is at the end. So we would add the zeros in here. So if I wrote this out, this is really the same thing as 23,100,000. So that's how we would do this, is we would just add our commas for every 3 decimal places. And for the last one, this time we're going to go the opposite direction. So I'm going to move it over 1, 2, 3, 4, 5 places. So I would put in 4 zeros in front of the 5, 2. So the answer to this one would be 0.1234 zeros, 5, 2. So I did move it over 5 places because originally it was between the 5 and the 2. As always, thanks for watching. If you have any questions, please let me know. If there are additional topics that you would like me to cover, please let me know that as well.